So today we are going to synthesize a phenetoin drug molecule. So while submitting this phenetoin drug molecule, we are going to submit the recrystallized product of phenetoin. Before that, we are going to calculate the theoretical yield, that approximately how much amount of drug we can synthesize. Then we are going to calculate the percentage yield and melting point of the drug molecule. Now, so the requirements which are required for the particular synthesis of a phenetoin drug molecule, we require urea, nitric acid, benzoin, sodium hydroxide as an alkaline solution, ethanol as a solvent, then concentrated hydrochloric acid, and particularly we are synthesizing this drug molecule in the round bottom class. Now, what will be the synthesis of phenetoin or principle behind this synthesis? So what happened when this urea molecule, so this phenetoin is 5,5-diphenyl imidazole. So this is the structure of phenetoin drug molecule, and it is a 5,5-diphenyl and imidazole ring is there. So in the last practical only we have done the synthesis of benzimidazole molecule. So here we are going to synthesize a substituted imidazole ring, that is phenetoin. What is phenetoin? Phenetoin is 5,5-disubstituted imidazole molecule. So 5,5-disubstituted means 5,5-diphenyl imidazole 2,4-dione. So here the chemical name of phenetoin is 5,5-diphenyl 2,4-dione. So two ketone functional groups are there, and the parent ring is imidazole. So how it is synthesized? So benzene react with the urea in the presence of alkali and alcohol to give phenetoin. So this is basically the structure of benzene molecule. So the typomystic is there. So this benzene one react with the molecule of urea in the presence of alkaline solution, that is sodium hydroxide. It is going to synthesize phenetoin drug molecule. So earlierly it is going to synthesize an intermediate product, which upon cyclization mechanism or condensation mechanism, there is synthesis of phenetoin drug molecule. Now, what will be the procedure for synthesis of phenetoin? Phenetoin is synthesized from benzene and urea. Just now we have seen the reaction. See. So we have seen this reaction from benzene molecule. When this benzene molecule will react with the urea, it is going to synthesize the phenetoin molecule. So what happened? We are synthesizing phenetoin molecule from benzene, but before that we have to synthesize a benzene molecule from benzoin. Now this particular synthesis we have done in the lab. So when you have resumed your college, so that time we have synthesized benzene molecule. So what is the procedure for synthesis of benzene molecule? 2 grams of benzoin and 5 ml of nitric acid in round bottom fast we have taken at that time, and we have heat the reaction mixture on a water bath. So till it get crystallized out. So this benzoin is replaced by oily benzene. So from when the benzoin molecule will react with the nitric acid, so it is going to give the benzoin molecule, and which is replaced by the oily benzene. So this reaction mixture, which is oily or droplet crystals are there, pour the mixture in a beaker containing cold water with a stirring until the oily benzene crystallized out in the yellow solid. So this oily benzene will be converted into the yellow solid compound. Now next, so the preparation of phenetoin from the benzene. Now benzene we have prepared from the benzoin by reacting benzoin with the 5 ml concentrated nitric acid. Now this synthesized benzene will react with the urea to form phenetoin molecule. So what happens after that? 1 gram of benzene will react with 1 gram of urea. Equimolecular reaction is there. 1:1 ratio, they are reacting with each other in the presence of in the presence of sodium hydroxide and 20 ml of ethanol in the round bottom flask. So it is going to give boil this reaction mixture for 2 hours and cool the mixture to attain the room temperature. So first of all, we are going to boil this reaction mixture for approximately 2 hours as it is a ring closure reaction. So it will require higher heat timing will be more, and later on we are going to cool the reaction mixture to attain the room temperature. Now pour the mixture in 100 ml of cold water and mix. The mixture is allowed to stand for 15 minutes. So filter and remove the insoluble byproducts which are there in the synthesized product. Render the filtrate strongly acidic with concentrated hydrochloric acid. Cool the filtrate in ice cold water and filter the precipitate product and submit it. So this is all about how we are going to synthesize the phenetoin drug molecule. Now, how we are going to get confirmation that whether all benzoin molecule or whether the benzoin is converted into phenetoin or not. For that, we are going to do some identification chemical test for that phenetoin drug molecule. So those identification tests are, we are going to take the sample solution, which is crude benzoin, phenetoin, which we have synthesized. So this phenetoin solution, and to it we are going to add hydrochloric acid. So if the phenetoin is there, it will give the white precipitate. So when phenetoin drug molecule will react with hydrochloric acid, it is going to produce a white precipitate. So we have confirmed that the benzene molecule is converted into, or it is synthesized into the phenetoin drug molecule. Now the next synthesis is, to the sample of phenetoin drug molecule, we are going to add pyridine and copper sulfate solution. So this copper sulfate solution in the presence of a pyridine, if it is going to produce the blue color, so that means it is confirmed that the synthesized product is phenetoin in nature. So we are going to report the yield of the synthesized product in the form of percentage yield and melting point. So this is about the synthesis of phenetoin molecule. Now our next synthesis is the synthesis of benzocaine. How we are going to synthesize the benzocaine drug molecule? So the synthesis of recrystallized product of benzocaine from para-amino benzoic acid. So we are going to calculate the yield. So benzocaine molecule, as it is an anesthetic agent. So this benzocaine we are synthesizing from PABA, that is para-amino benzoic acid, and calculate the percentage yield and melting point of the product. So how we are going to do the synthesis? What is the principle behind this particular synthesis? Benzocaine is ethyl ester of para-amino benzoic acid. Benzocaine, which is used as an anesthetic agent, which is nothing but the ethyl ester of PABA molecule, that is para-amino benzoic acid. And it can be prepared from the PABA and ethanol by Fischer esterification. So PABA, when it is reacting with the ethanol molecule, it is going to synthesize ethyl para-amino benzoic acid, as it is an ester of a PABA molecule. PABA means para-amino benzoic acid. Acid, when react with the alcohol, they are going to form the ester bond, and this formed ester bond will be a benzocaine molecule, which we are going to use as an anesthetic agent. Now, how we are going to confirm, or how the procedure will be done? So, what is the procedure for the synthesis of benzocaine molecule? Through the 100 ml round bottom flask, check 8 ml of ethanol, that is solvent, and which is used as a reaction mixture here. So this ethanol plus we are going to add 4.12 grams of para-amino benzoic acid. So this acid will react with the alcohol molecule, that is ethanol, and 1.2 ml of concentrated sulfuric acid, and keep this reaction under reflux for 1 hour. We are going to make the reflux. Now we have already seen how the attachment of reflux condenser is done in our lab. So heat this reaction mixture for 1 hour. Upon cooling the reaction mixture, set to a solid mass hydrochloric of ethyl para-amino benzoate. Now pour this hot solution in the excess of water and add sodium bicarbonate to clear the solution until it is neutral to the litmus. So filter and wash the dye product. Now, what will be the identification test for the particularly for whether the benzocaine molecule is synthesized or not. So this sample solution of benzocaine, we are going to add the nitric acid and concentrated hydrochloric acid and cool the reaction mixture. To this solution, we are going to add beta-naphthol solution. So this beta-naphthol in the sodium hydroxide maintain the temperature when this reaction mixture is going on. We have to maintain the temperature between 0 to 5 degrees centigrade. So what happened? We are going to take the benzocaine, which is crude synthesized benzocaine, add concentrated hydrochloric acid and cool the reaction mixture. And to this cooled reaction mixture, we are going to add a solution of beta-naphthol in the sodium hydroxide. So, and this reaction particularly carried out at the temperature of 0 to 5 degrees centigrade. So it is going to produce the deep red color. So we can confirm that benzocaine is confirmed. So the report of the, so we are going to report the synthesized product, percentage yield of synthesized product. So we have today discussed the synthesis of Today we have discussed the synthesis of phenetoin drug molecule having a different category which is used as an antiepileptic agent. And next, just now we have seen the anesthetic agent, that is benzocaine. Now the next and very important experiment which we are going to study is assays of particular drug. Now you have done the assays already in the pharmaceutical analysis. That time you come to know that what do you mean by assay of any drug. So we are going to confirm the purity of that drug molecule. How much amount of purity it is there when it is given in the as a pharmaceutical agent or is a drug molecule. So some of the drug assays are there for your syllabus. That is assay of. So from that, first we will discuss the assay of aspirin drug molecule. So the assay of aspirin includes, we require aspirin as a drug molecule, then sodium hydroxide solution 0.5 normal, hydrochloric acid 0.5 normal, phenol red solution and butyrate. So first of all, before we proceeding for the assay of any drug, we have to standardize the chemicals. We have to standardize the normalities of given solutions which are required for the determination of percentage purity of the drug molecule. Now, what we are going to do, we are going to first standardize the 0.5 molar hydrochloric acid. So for that, we are going to weigh 0.75 grams of anhydrous sodium carbonate, which is previously heated at 270 degrees centigrade. So this, we are going to take the sodium carbonate 0.75 gram, which is dissolved in the 100 ml of water, and to it add 0.1 ml of methyl red solution. Now this solution we are going to titrate slowly from the burette with a constant stirring until the solution becomes faintly pink. So what we are going to do, we are going to do the titration of hydrochloric acid with the sodium hydroxide solution. So heat the solution and cool and continue if the pink color fades on the heating continues. So this process we are going to continue until the faint pink color is produced up to 30 seconds in the reaction mixture. So for if it is so no longer, then they are going to affect the percentage purity of the drug molecule. Now, what is the main procedure for the assay of aspirin molecule? So weigh accurately 1.5 gram of aspirin and dissolve it in 15 ml of ethanol. So we are going to weigh 1.5 gram of aspirin and it is dissolved in 15 ml of ethanol, which is added to it. We are going to add 50 ml of 0.5 molar sodium hydroxide solution and boil this reaction mixture for 10 minutes. Cool and titrate this reaction mixture with excess of alkali with 0.5 molar hydrochloric acid. So what we have taken? We have taken 1.5 gram of aspirin, which is dissolved in the 15 ml of ethanol, and to it we are going to add 50 ml of 0.5 molar sodium hydroxide solution. So what happened after that? So we are going to boil and gently this solution for 10 minutes and cool and titrate with the excess of alkali with 0.5 molar hydrochloric acid. This particular titration we are going to do in the presence of phenol road solution as an indicator and perform a blank determination. This procedure will be done in the presence of aspirin drug molecule as well as in the absence of aspirin as a drug. Now the meaning of the blank determination means similar procedure we are going to follow for the blank determination without taking the sample. So only we are going to exclude the intake of aspirin molecule. Rest all chemicals we are going to take in the determination of blank. That is 15 ml of ethanol we are going to take. We are going to take 50 ml of 0.5 molar sodium hydroxide solution. Then boiling for 10 minutes and cool and titrate this reaction mixture with 0.1 normal hydrochloric acid. So only the changes we are going to perform the blank determination to calculate the difference between the titration represent the volume of sodium hydroxide consumed. So we are going to check how much amount of sodium hydroxide is required to neutralize or required to determine the percentage purity of the aspirin drug molecule. So for that calculation, we are going to derive one formula, that is depending upon the molecular weight of that sample. So how we are going to determine the formula? Each ml of 0.5 molar, 0.05 molar sodium hydroxide solution will produce 0.04504 grams of aspirin, which is equivalent to this much amount of aspirin drug molecule. So this is about the assay of a phenetoin drug molecule. Now our next synthesis is assay of phenobarbital. Assay means determination of percentage purity, and through titrimetric analysis, we are determining the assay or percentage purity of the drug molecules. So the first we have done with the aspirin. Now we are going to consider about the phenetoin drug molecule. So what is it? So we are going to perform the assay of phenobarbital. So requirement for this particular synthesis is sodium hydroxide, aldehyde-free ethanol, benzoic acid, and thymophthalate solution. Silver nitrate, pyridine, ether, conical flask, burette, beaker, and pipette. Now what is the principle for the synthesis of phenobarbital? It is assayed by non-aqueous titration. See, in the case of aspirin drug molecule, it is an acid-base titration. Here, the aspirin phenobarbital drug molecule is assayed by non-aqueous titration. Now, in this method, the drug, that is phenobarbital, is dissolved in the pyridine solution, and this pyridine solution, along with will be titrated with sodium hydroxide solution is using thymophthalate as an indicator. So how we are going to synthesize the phenobarbital? So phenobarbital, when it is reacting with the alkaline solution, it is converted into phenobarbital sodium. So they are going to form the crystals of phenobarbital sodium. Now the procedure for the particular synthesis of phenobarbital sodium. What is the procedure? Standardization of sodium hydroxide solution. Before we move actually towards the synthesis, we have to standardize the chemical, and this standardization will be done of a sodium hydroxide solution. So very accurately, about 0.6 gram of benzoic acid and dissolve it in a mixture of 30 ml of ethanol. So we are going to weigh first of all the 0.6 gram of benzoic acid and dissolve it in a mixture of 30 ml of ethanol and 6 ml of water. So after that, when it is titrated with ethanolic sodium hydroxide solution using 0.2 ml of phenolphthalein as an indicator. So 6 gram of benzoic acid, dissolve it in a mixture of 30 ml of ethanol and 6 ml of water, and particularly titrate this reaction mixture with the ethanolic sodium hydroxide solution until 2 ml of phenolphthalein, which is used as an indicator. So this is about the standardization. Now the main of the aim of the experiment is assay of phenobarbital. So how we are going to proceed further for the assay? For that, we are going to weigh a powder 20 tablets. Randomly, particular drugs 20 tablets we are going to take and weigh in a quantity of the powder containing about 100 gram of the phenobarbital. So first of all, we are going to crush those 20 tablets, and out of which only 100 milligram of phenobarbital we are going to dissolve in 5 ml of pyridine and 0.25 ml of phenolphthalein. So after that, add 10 ml of silver nitrate pyridine reagent and titrate it with 0.1 molar methanolic sodium hydroxide solution until the pure blue color is obtained. So when the blue color or pure blue color is obtained, same operation we are going to repeat without the substance, that is blank determination, under the examination. So after that, the difference between the titration of blank and the crude drug molecule, it is which will represent the amount of sodium hydroxide required for the synthesis. So environmental factor for the calculation of percentage purity is 0.1 ml of 0.1 molar ethanolic sodium hydroxide solution is equivalent to the percentage purity of phenobarbital which is to be synthesized in the drug. Today we are going to stop here. Yes, is there any doubt?
No, ma'am.
Okay, I will upload this recorded practical in the YouTube channel. Go through it, and I will share also the soft copy for your reference. All those 3 experiments